Let's take a look at this practice test. You can see we have a list of data over here on the right, and we are tasked with comparing some statistics on it. For this question, we're looking at the mean, the median, the mode, and the range. And we are doing it for points per game. It says it right there. So the points per game is this column right there. PPG stands for points per game. And it is currently in order, which will help us when we're looking for the median, the mode, and the range. The mean, we need to add them all up and then divide by the amount of numbers there are. So when we add those all up, we get a total of 129.5. There are a total of 15 numbers, so we're going to divide that by 15. And when we do that calculation, we get 8.63 repeated. I'm just going to round that to 8.6 for our mean. The median is the middle number. Since there are 15 numbers, if I go 7 from the top and 7 from the bottom, I should find my middle one. So we go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And we can see it leaves us with this middle number right there. So the median is 7.3. The mode does not exist. There is no number that is repeated. Since there is no number that's repeated more than once, there is no mode. So I'm going to write none right there. For the range, we're going to take our lowest number and our highest number, find out their distance. So we're just going to do 21.9, subtract that 1.6, and when I do that, I get 20.3 as the range, so 20.3. Our next question asks us to do some stuff with the standard deviation. I don't need you to calculate the standard deviation. I've done that for you. It's given right there. That symbol sigma is for the standard deviation, so it's 5.38. And our first question says, how many jazz players' points per game are within one standard deviation of the mean? So we've drawn this picture quite a bit where we had the mean and we went out by a standard deviation like so. So we're going to use that picture to get us some high and some low points to be able to figure out how many of those players are in that range. So last slide, we just calculated the mean. So taking a look at that, it's 8.6. So we're going to have 8.6 here in the middle. And we're going to go up and down by a standard deviation, which is given up here. It's 5.38. So I'm going to add 5.38, and I'm going to subtract 5.38 from our 8.6 from our mean. When we add that 5.38, that puts us at a value of 13.98. And when we subtract 5.38, that puts us at a value of 3.22. All right, so it asks us how many players are within that one standard deviation. This now gives us our high and our low point. So we're going to take a look at this list of data and see where those lie and just look at who's in the middle of those two endpoints. So 3.22 would be right here on our list. 13.98 would be right here on our list. So we now have our upper and our lower bounds, and we take a look at how many players are there in between. Counting that up, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 players within one standard deviation of the mean. When we do percent, we're going to take that 10 and we're going to divide it by our total number of players. So 10 out of a total of 15 players, 10 divided by 15 ends up being 0.67 when we round it, or 67%. You can write it in decimal form or you could write it in percent form, 67%. I really don't care, but make sure you don't write it as 0.67%. That would be incorrect. So either write it as 0.67 or 67%. Either one of those would be acceptable. All right, moving on to the next question. This asks us to take a look at how many players are within 2 standard deviations of the mean. So we need to take our picture at the bottom and we need to go out by another standard deviation this way and go out by another standard deviation that way. So we're going to add another 5.38 and we're going to subtract another 5.38 to each end. When I add that 5.38, I get 19.36, and when I subtract that 5.38, I get negative 2.16. All right, now negative 2 would be way down here. It doesn't matter that it's past the bottom one, that's fine. 19.36 will be right there. Let me erase my old lines here, clean this picture up a little bit. So we're going in between those two values, and we need to count how many are there. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 players belong in between those two values. Go back to our percent, we're going to do 14 out of 15. And that gets us 0.93 repeated. Rounded, that would be 93%. So again, you can write it in percent form, 93%, or you could write it in decimal form, 0.93. Either one would be fine with me. Within 3 standard deviations of the mean, we need to go out one more standard deviation in either direction. So that gives us another 5.38 above and 5.38 below. The lowest value now is negative 7.54. That doesn't actually make any difference because that's still down here below the very last player. But the top end does make a difference. That puts us up at 24.74. And that would be up here above the top player. So we have now captured every single player in this list. That was a total of 15 players. And if we do a percent, 15 divided by 15, 15 out of 15, that would be 100% or 1 in decimal form. So you could either write that as 1 or 100%, but please do not write it as 1%. Next question asks if there are any players that are outliers. Taking a look at this list, we could argue that Gordon Hayward is an outlier from all of the rest because he is a significant distance away from this next one. It's 4, and all of the others are fairly close. George Hill is about 4 away from here, so that would be an argument against Gordon Hayward being an outlier. So you could go either way. Really what I'm looking for is a explanation of why you feel it is or isn't an outlier. So I'm going to say Gordon Hayward is an outlier. He is quite a bit above the rest of the list when you look at how close the rest of these are. 4 is a pretty significant difference. Next question asks us to do a histogram, and our bins are already established for us right here. So we're going to draw our x and our y-axis. The y-axis is always labeled frequency, and our x-axis will be labeled according to those bins. So we're going by 10s, 1 to 10, 11 to 20, 21 to 30. So I'm going to start with 1 here, and I'm going to go 10, then I'm going to go 20, then I'm going to go 30, 40, 50, and we got to go all the way up to 70, so 60 and 70, and try to space those out nicely. All right, this we are using the games played data, so that's in this column right here. I didn't like that it was out of order because it's harder to count them, so I put it in order over here in this list, and we can take a look and find what belongs in each of the bins easier. So here we have a 10. 10 belongs in our 1 to 10, so there's 1 in that category. We're going to fill out this frequency table so we know what our tallest bar is before we start to draw them. All right, so we cross that off. Next, 11 to 20, we don't have any, so I'm going to put a 0 there. 21 to 30, we don't have any again, so I'm going to put a 0 there. 31 to 40, we have 1, 2, 3, so there's 3 in that category. 41 to 50, we have 1, 2, 3, 4. 51 to 60, we have 1, 2. 61 to 70, we have 1, 2, 3, 4, 5. For a total of 15. Make sure that when these are counted up, they should add up to 15. All right, let's take a look at our histogram now. We're going to draw those bars. We can see that the tallest one is going to be 5. So our y-axis for frequency needs to go up to 1, 2, 3, 4, 5 at the height, that's top height. 1 to 10 has 1, so that's how tall that bar is. there are no players in the next two categories, so those are going to be empty. 31 to 40 goes up to 3. 41 to 50, oops, mistake there. I put that one in the 20 to 30 bin. The 31 to 40 bin will be over here. Goes up to 3. 41 to 50 goes up to 4. 51 to 60 goes up to 2. 61 to 70 goes up all the way to 5. If it was asked if there was an outlier, we would definitely say that the 10 is an outlier. That is very far away, and we can actually see that in our histogram sitting over here all by itself. All right, so we're going to describe this shape. First we have unimodal, bimodal, and multimodal. This, I would say, is bimodal. We can see a peak here, and we can see a peak here with a significant drop in the middle. So if we draw that curve, it kind of goes up, back down, and back up. I would not consider this one on the left a peak because it only goes up to 1 right there. Not tall enough, in my opinion, to be a peak. So this will be bimodal. And our explanation would be it has 2 peaks. So I just gave you that. Write that sentence there. Make sure you describe it fully. All right, next we're going to ask skewed to the left and skewed to the right or symmetric. This one is definitely skewed to the left. We can see over here it has a tail going off to the left side. So this is skewed left for sure. Skewed left. And our explanation will be that it has that tail off to the left. So make sure you write that in a full sentence. Which measure of center would we best represent the data? So we talked about this in 2 ways. If there's an outlier or if it's skewed to one side or another, then the mean is pulled out of place. Since this one is skewed, we are not going to use the mean because it skews it out of place. We are going to choose the median. So median, and our reasoning would be because the data is skewed over here to the left. All right. Box and whisker plots. We are still using the games played data. So again, this is why I put it in order, more so than the last one, but it was useful for the last one. So we're going to take a look at these, and we need to find the 5-number summary. Over here on the left, least, greatest, median, first quartile, and third quartile. Least is easy to spot because they're in order, so it's 10. Greatest is down here at the bottom, 69. So our number line needs to go from 10 to 69. You can see we have a little bit of extra space on either side of that number line because it goes from 9 to 72. It's okay to have a little extra space. All right, we need to find the median next. So we're going to go to the middle, just like we did before. We get 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And so the middle number right there is 49. That is our median, 49. First quartile now, we need to take this top half and we need to, this smaller half, I guess, and we need to find the median of that. We know that there are 7 numbers, so we're going to go 3 and 3 and find the middle. So 1, 2, 3 on this side, 1, 2, 3 on that side, and our middle number right there is 39. So that's our first quartile, 39. Third quartile is the median for this bigger half of numbers. So we're going to go 1, 2, 3, 1, 2, 3, just like we did before, and there is our third quartile. It is 63. Now we have everything that we need to draw our box and whisker plot. So we come down to the number line, we put those 5 points on the number line where they belong. So there is 10 for our least value, 69 over here for our greatest value. The median is at 49, so that would go right there. First quartile is at 39, so that would go there. Third quartile is at 63, so that would go there. We're going to draw our whiskers out to either side, draw our box around the middle with the line down the center, and you can see that it is skewed left because that whisker is pulled over to the left, so that matches what we said with the histogram earlier. All right, we need to calculate the interquartile range. That would be the range in between the first and the third quartiles. So we have the first and the third quartiles listed here. We go from 63 down to 39. The range is just subtracting those. So we have a total of 24 for the interquartile range. The interquartile range tells us where the middle 50% of players lie. So the middle 50% of players had a range of 24, or you could say that they're between 39 and 63. Those amount of games right there. Either one of those sentences would be accurate because we're saying it's between the quartiles. All right, the left whisker, what does that tell us about the games played data? The left whisker goes from 10 to here, the first quartile, from 10 to 39. And we know that there's 25% of the players that fit in that category. So we would say the lowest 25% of players were between 10 and 39 games played. So that would be the sentence that I would put right here. The lowest 25% are between 10 and 39 games played. What does the right whisker tell us about games played? The right whisker is over here. It also contains 25% of the data, but this one we can see goes from the third quartile, which is 63, to the maximum of 69. So one possible sentence could be that the top 25% of players played between 63 and 69 games. I have had lots of people answer these questions in a different way. For example, we could say the left whisker tells us that it's skewed left, or because it's more stretched out, or the players over here at the low end are more spread out than the players here at the high end. There's a lot of different sentences you could say, and I would accept all of those. So I just gave you a few samples for possible answers right there. All right, we finally got to this question. Are there any jazz players whose games played are outliers? We said this before, this 10 is definitely an outlier right there. So yes, definitely, that player was Joel Bolomboy. So we're going to say Joel Bolomboy is an outlier because he has far fewer games than anybody else played. So that would be your explanation right there. That concludes our practice quiz, and I wish you luck on the quiz. Thank you.